Significant increases in operating weights of air transport and corporate aircraft have made stopping on a runway an important consideration for aircraft designers. It is increasingly difficult for conventional disc brakes to stop high-speed, high-gross-weight aircraft in relatively short landing distances at some airports. The turboprop aircraft uses a highly effective propeller reversing system, but the turbojet and turbofan aircraft do not have the luxury of large, powerful propellers to create a reverse thrust. As a result, an airflow reversing system is incorporated to reverse the exhaust gases as they leave the nozzle. Airliners powered by turbojets and turbofans, most commuter aircraft, and an increasing number of business jets are equipped with engine thrust reversers to aid in braking and directional control during normal landing, reduce brake system maintenance, provide braking and directional control during emergency landings and rejected takeoffs, increase the aircraft's rate of descent by acting as speed brakes, back an aircraft out of a parking spot in what is called a power back operation. Reversers are especially helpful when landing on wet or icy runways and provide approximately 50% assist in stopping the aircraft. The normal way to operate this system is to apply reverse as soon as the aircraft is firmly on the runway, and then to apply as much reverse power as necessary for existing conditions such as water, ice, and so on. When the aircraft slows to approximately 80 knots, power is reduced back to reverse idle and then to forward thrust as soon as practical. Most thrust reverser systems can be divided into two categories: aerodynamic-blockage and mechanical-blockage. In the aerodynamic-blockage type of thrust reverser, used mainly with unducted turbofan engines, only fan air is used to slow the aircraft. A modern aerodynamic thrust reverser system consists of a translating cowl, blocker doors, and cascade vanes that redirect the fan airflow to slow the aircraft. If the thrust levers are at idle position and the aircraft has weight on the wheels, moving the thrust levers aft activates the translating cowl to open, closing the blocker doors. This action stops the fan airflow from going aft and redirects it through the cascade vanes, which direct the airflow forward to slow the aircraft. Since the fan can produce approximately 80% of the engine's thrust, the fan is the best source for reverse thrust. By returning the thrust levers to the idle position, the blocker doors open and the translating cowl closes. Mechanical blockage is accomplished by placing a removable obstruction in the exhaust gas stream, usually somewhat to the rear of the nozzle. The engine exhaust gases are mechanically blocked and diverted at a suitable angle in the reverse direction by an inverted cone, half sphere, or clamshell. This is placed in position to reverse the flow of exhaust gases. This type is generally used with duct turbofan engines, where the fan and core flow mix in a common nozzle before exiting the engine. The clamshell type or mechanical blockage reverser operates to form a barrier in the path of escaping exhaust gases, which nullifies and reverses the forward thrust of the engine. The reverser system must be able to withstand high temperatures, be mechanically strong, relatively light in weight, reliable, and fail-safe. When not in use, it must be streamlined into the configuration of the engine nacelle. When the reverser is not in use, the doors retract and nest neatly around the engine exhaust duct, usually forming the rear section of the engine nacelle. Operating in reverse thrust at low ground speeds can cause re-ingestion of hot gases and compressor stalls. It can also cause ingestion of fine sand and other runway debris that can abrade gas path components and even make its way through main bearing air oil seals into oil sumps. The normal operating procedure for thrust reverse is to select reverse after touchdown at ground idle speed and reapply power to approximately 75% N2 speed. A thrust reverser must not have any adverse effect on engine operation either deployed or stowed. Generally, there is an indication in the flight deck with regard to the status of the reverser system. The thrust reverser system consists of several components that move either the clamshell doors or the blocker door and translating cowl. Actuating power is generally pneumatic or hydraulic and uses gearboxes, flex drives, screw jacks, control valves, and air or hydraulic motors to deploy or stow the thrust reverser systems. The systems are locked in the stowed position until commanded to deploy by the flight deck. Since there are several moving parts, maintenance and inspection requirements are very important. While performing any type of maintenance, the reverser system must be mechanically locked out from deploying while personnel are in the area of the reverser system. Thanks for watching.